You know, some of the most powerful forces in our world, we're talking everything from how money grows to the sheer power of an earthquake, they operate on a scale that's, well, it's just really hard for our brains to wrap around. But what if I told you there's a secret mathematical language that makes it all click, one that connects things you'd never ever think to put in the same sentence?
I know. It sounds like the setup for a really weird joke, right? But seriously, there is a deep mathematical connection between all of them. They all have to do with explosive growth and massive, massive ranges in value. And to really get them, you need a special set of tools.
Just look at this for a second. The difference between a whisper and a jet engine, or a tiny tremor you can't even feel, and a quake that levels a city. It's just astronomical. I mean, how do you even begin to work with numbers that are so wildly different? If you tried to plot these on a regular graph, you'd need a piece of paper that's miles long. It's a huge problem of scale. So to figure this out, we first have to understand the language of that crazy, rapid, continuous growth itself. And believe it or not, that story starts with a simple question about making money. So this is our guy, Jacob Bernoulli. Back in the late 1600s, he wasn't trying to unlock the secrets of the universe. Nope, he was just trying to figure out a really practical problem: how to get the best possible return on an investment.
So he posed this simple question. Imagine you have $1 and some bank offers you this unbelievable 100% interest rate for a year. If they just pay you that interest once at the very end of the year, you turn your dollar into $2. Easy. But what if they calculated and paid out that interest more often?
And this is where it gets really interesting. Look at what happens. If you compound twice a year, semi-annually, you get $2.25. If you do it monthly, you're up to over $2.61. Daily gets you to about $2.71. See the pattern? You're making more money, for sure, but the extra amount you get each time is getting smaller and smaller. It's not just shooting off to infinity, it's actually approaching a limit. And that limit is this special number. We call it E. It's a lot like pi. It's what we call an irrational number, meaning the decimal points just go on forever and ever without repeating. And what Bernoulli accidentally discovered here wasn't just about money. Oh no. It turns out E is the fundamental constant for all kinds of perfect, continuous growth, whether you're talking about a population of bacteria, radioactive decay, or your bank account.
So his discovery led directly to this incredibly powerful formula. Here, P is what you start with, R is the interest rate, T is time, and right in the middle of it all, there's our number E. This is the key. This formula is the mathematical blueprint for anything that grows smoothly and continuously.
And here's where it gets real. Forget about your savings account for a second. Think about a loan shark. Let's say they charge 35% interest compounded continuously. That means a simple $1,000 debt nearly doubles in just 2 years. That is the brutal, unforgiving power of exponential growth in action.
Okay, so we've seen how exponents and the number E describe this kind of explosive growth, but how do we, tame it? How do we make those gigantic numbers easy to work with again? For that, we need a translator. We need the logarithm.
A logarithm sounds super complicated, but I promise you the basic idea is really simple. It's just the reverse of an exponent. It basically asks, hey, what power do I need to get this number? For instance, we all know that 10 squared, or 10 to the power of 2, is 100. A logarithm just flips that around. It asks, 10 to what power gives me 100? And the answer, of course, is 2. That's all a log is doing, is finding that hidden exponent.
I love this analogy. It's the perfect way to think about it. A logarithm acts like a giant compressor, or maybe a funnel. It can take a huge chaotic range of numbers, like say from 1 all the way up to 1 billion, and it shrinks it down into a nice, tidy, manageable range, like 0 to 9. This power to compress is what lets us make sense of the world. So, now we can finally go back to our original question. That compression power is exactly why we use logarithms to measure all those things like acidity, earthquakes, and even sound.
Let's start with chemistry and your coffee. When scientists are measuring how acidic something is, they're dealing with hydrogen ion concentrations that are often these ridiculously tiny numbers with tons of decimal places. It's just a pain to work with. So back in 1909, a chemist came up with this brilliant, elegant solution. He said, hey, let's just take the negative logarithm of that messy number. That log right there in the formula is our compressor doing its job, turning those awkward decimals into nice, simple numbers, usually somewhere between 0 and 14.
And here's the thing you absolutely have to get about this. Because it's a logarithmic scale, a change of just one single number means a tenfold change in reality. So, your coffee with a pH of around 5 is 10 times more acidic than pure water at a pH of 7. Battery acid? We're talking millions of times more acidic. The pH scale makes these huge differences easy to talk about.
And it's the exact same idea when it comes to measuring the terrifying power of an earthquake. The energy they release can vary by just mind-boggling amounts.
So Charles Richter came up with this formula. It takes the intensity of a quake, compares it to a tiny little standard tremor that we can barely detect, and then it takes the logarithm of that whole thing. Once again, it's our compressor squishing an enormous range of seismic power into a simple, usually single-digit scale.
And here's the key again. Just like with pH, every whole number you go up on the Richter scale means a tenfold increase in the shaking. So a magnitude 7 quake is 10 times more intense than a 6, and 100 times more intense than a 5. Without this scale, the numbers would just be way too big to even report on the news.
And what about sound? Well, it turns out our ears actually perceive loudness in a logarithmic way, which is why we measure sound using, you guessed it, another log scale, the decibel scale.
A jet engine screaming by at 140 decibels is literally trillions of times more intense than the quietest sound a human can possibly hear, which we call 0 decibels. The decibel scale just compresses that incredible range into a number that we can actually use.
So we've gone all the way from compound interest to earthquakes and jet engines. So what's the big idea here? What's the thread that ties this all together? And how does knowing this stuff change the way we see everything?
It all comes down to this really beautiful symmetry. You've got one function, the exponent, that describes the wild, untamed, explosive nature of continuous growth. And then you have its perfect inverse, the logarithm, which is the tool our clever human brains invented to tame that growth, to translate it into a language we can actually understand. There are two sides of the exact same coin, the essential toolkit for understanding anything that operates on a truly massive scale.
From the interest compounding on your credit card debt, to the way information spreads online like wildfire, exponential growth is absolutely everywhere. But now, you know the language. You know the secret code of exponents and logs. And you're going to start seeing it and understanding it in a completely new way. The only question is, where are you going to spot it next?